Hello, ladies and gentlemen. So this is Wollər Dynamics and we're back with another video on meshing. So revisiting this case, this sphere. So in this case, just to introduce this twist, probably a little bit more about mesh quality and geometry, how to do this. So I not want to go into details in the video description. You have how I did it. Probably didn't follow the best step how to do this, but I have something. So if you want, do that. And this is to stress that I mentioned that it's extremely, when you do the mesh, it is extremely important to control your geometry. And since to the fact that I control this geometry, I can do this stuff. Okay, so it might be the case that you need it or to show off, doesn't matter, but look at the amount of control that I have. So basically I exported this surface, I have everything, and to mention that this same stuff can be done also with Mesh Mixer that we have been using. Fantastic tool, probably I'm going to show you how to do it, probably not. Any case, let's move. So we go back to our case. So the first thing is that let's revisit the previous case now, and I rerun this case. On my boundary layer now I have 30 layers. So if I use here the default values set up, it's not going to fail. Now I change mean determinant and I have a mesh. Okay, so let me go log check mesh BL, and these are the quality metrics, perfect mesh, and so on. So let me open Paraview and let's visualize the mesh. Okay, so remember that I always put these states, and you have two states there. So the first one is the one that we have been using so far. Always check there, that is already, and we have our nice mesh there. Okay, everything perfect. But let's open the other because I want to talk about that precisely one, the other one. Okay, so let me go here, load state, Paraview, Paraview 2, and there you go. And look at what I have here. Okay, we're going to talk about this workflow. But first, 30 cells, these are our quality metrics. I have an aspect ratio 197. Okay, using uniform. Remember that when you are doing the snapping and the surface, sometimes you get shorter, larger cells, and it will differ. Okay, but this is what I have using this linear progression, and I believe in this. Now, if we look here, this is my workflow, my pipeline. Look at that. You have a filter called mesh quality. So I read you read everything, mesh quality, and you can set here. So for all of them, I chose the edge ratio. Okay, so there is a help somewhere in the internet. I don't recall the link. I didn't save it, and they explain all these quality metrics. So as you see, when it comes to meshing, to meshes, there are many quality metrics, and it appears that it's easier to identify a bad one than a good one. But in this case, we're interested in edge ratio. Okay, edge ratio is the aspect ratio. So in Paraview is defined, and in my Excel here is defined as the longest edge, the ratio between longest edge and distance from the wall to the other node. Okay, here, this distance. It's not cell center here, it's measure it to the other node. So if you want to talk about finite volume divided by 2, okay, so that is another correction, but it's not going to change much what you're doing. But here you get an idea. I plot this, and you choose node because you have different elements. So you have triangles and surfaces, quad, TED, pyramid, wedge, hexes. There are no polyhedron. So this that you see here, blue, that are in 0 because they are poly and there is no quality metric. So if the guy from Paraview are watching this, and I hope, because it means that we have a good community, please add a quality metric for poly. And guys, this is what we have. So here you can see that it's measured as that. So let me change the scale and put here 200. And already I can see that all these cells, you have 200, the others that are poly, they are not showing, but you start to see that this is going to fail. Okay, in OpenFOAM, when you reach the value 100, it's going to fail. So here you have already this visual. I always do it. I recommend you to do this visual check. Okay, it's very helpful to identify scenes. Sometimes you can find some regions that maybe you can add some localized refinement. So try to do it. Okay, it doesn't cost anything. And then also sometimes I use threshold, this one, the threshold. So you put it there, and well, you need to change your filters. Let's put here 200, and let me increase this one to 50. Now to see kind of the volumetric values, and you get the idea what is happening, okay? So all these cells, they have values more than, let's put here, than 100, and this will trigger the collapsing of the boundary layer. So there you go, you have that visual inspection. So I recommend you to do this also when you start to have problems and so on. Okay, so it's filters, mesh quality, somewhere there you find it. Okay, I always get lost there, so you just do search. And that's it. That is one thing that I wanted to show you, that you can visually get that, but also you have, remember that you have the check mesh. Okay, and you can get it from here, but look at that, it's completely different. The aspect ratio that is computed in the same way, by the way, same principle, but there are some corrections here. It's predicting 37, we have 200. Okay, so there are some corrections and so on. Okay, so that's what I wanted to show you. Okay, by the way, you can look at the source code. Now you have a Snappy. I don't recall where is that, but I recall that probably in one of the first video I showed the location, or in the slides where you have all those quality metrics, so revisit that. But now what I want to show you to do, so that was regarding quality, how to do this. So we know at this point, and I really hope we know how to use snappyHexMesh very well. We have been doing this for a while. So basically rig the geometry. I call it wall face. You have everything, nothing changed. So let me add, because I know that I have sharp angles, or I want to capture that sharp angles, because you can do this tribal projection and put the face and try to refine on top of that, but it will look nicer getting the sharp angles. So surface features, extract this one, and look at that, I'm using this distant mode. This is the one I recommend you to use. This one, it will force to snap to the edges, but it's not going to do a very good job adding refinement. So if you put 6 there, this is better. So the first number is the distance from those edges, and then the second is the refinement. This one, you can add different refinement. This distance, and so on. We also talk about that. The body, this one, okay, then you can go and say, okay, as I read this geometry, I can go and put a surface refinement on that. It will work. I don't recommend you. We already addressed the issues. I don't recommend to take this approach. So you have it there, you can put like this, and if you run, you will realize a few small issues that they can be controlled. But as usual, to control that, you will need finer meshes, and probably that is not what we want to do. We want to keep with this quartz mesh, okay? So I don't recommend to take this. The way I like to do it is to use refined regions. You have that region, and in this case, I want to refine everything inside that region, okay? So I'm going to get this sphere, everything inside, and refinement of force. You can also use distance, it's up to you in this case, and see that we're going to refine the edges and then inside. So we're going to get that imprint on the mesh surface. Very cool, very nice. The rest boundary layer, everything will work, okay? Well, be careful that if you use this approach and you put here internal baffles, not going to work the boundary layer, it only works with boundary. We also study that. If not, go back to the previous videos. So that's all, and let's go and let's generate this mesh. So now here we start from scratch, and off you go. So let's wait for our mesh and take a look at the output and see if you see something strange. Okay, we have a mesh, we're back, quality, nothing to talk about that, perfect mesh. Also the log file is perfect. Remember, I told you just to take a look. Doesn't mean that something strange is going to happen. It was perfect, but always take your time. Simple cases, evaluate, get familiar with what is happening. And yeah, it was a little bit more time consuming. Remember that we have finite stuff, a refinement of 6 and so on. So let's take a look at our geometry. So basically we have this, and yeah, let me open the state Paraview there, and okay, and there you go. So let me rotate it. Cool, super cool, voila. And then for our next Christmas card, I already know what I'm going to do. So there you go, nice. So the refinement on the edges and so on, and see that put a 4 inside, perfect. So this is the power of knowing your geometry and knowing how to control your options, okay? So we didn't add boundary layer, later we are going to add that. Before that, I'm going to show you something else, which by the way, I didn't also. I don't know if the boundary layer is going to work. It's going to work. Usually, yeah, remember, best practice boundary layer have something uniform when you have this refinement. And again, let me talk bad about those refinement. This 2-to-1 refinement is horrible. It's going to give you problems, but we have here, we know how to master everything, so it shouldn't be a problem. And there you go, very, very, very cool. So something interesting here that we have the boundary layer, the mesh, but we have this here, no? We have it there. So this is the step 1, okay? And then you do the snapping, and you can see now that from going from this to this, a lot of error in this snapping or interpolation to the surface can happen. So that's why finer meshes, better results. So it might happen that you will like to patch this to assign a boundary layer there, or well, put another color there when you're visualizing in Paraview. So we'll really visit this, but just to show you again, a super cool utility. I really, really, really like this utility, and I forgot where it was. Okay, probably here. Okay, I commented. Here, I put it. So basically what you're going to do with this surface to patch, remember, it's going to read this STL and it's going to patch your mesh using this geometry. You have the tolerance option, play with that option, so it will give you better or worse results. If you don't put anything, we'll use the default value. If I were to call 10 to the minus 3, you will see difference, so I invite you to play. But let me go there, see that it's reading the mesh in 2, and now writing your result in 3. And let's see what we have as a patch mesh. Okay, delete, load state. So we created a new patch, okay? So that's important. And there you go. Let me hide and see that you have that patch there. And let me go, here. Okay, let me refresh, okay. Okay, here I need to select, see that it has this name mesh, okay? So if I go here, see that now you access, and there you go. So let me put here VTK, and voila. Nice, cool. But now this is a different patch, so you can apply there a boundary condition, I don't know, sorcerer, whatever you want. You can apply it there. So you have it there available. It has this name mesh, okay? So let me close here. Probably you know how it works. So you know that you can change that name here and whatever. But why that specific name? So we talk about STL files, OBJ files. So remember that here it was safe. And as a default name, we'll use the one that you put there. So that's why it was called mesh. It's nothing bad, no, it's not a big deal, but that's why it was mesh. Then you can change it. So let me close here, and at this point let's do the next step. The next step is let's add the boundary layer there. Okay, so very important here, we need to adjust our refinement dictionary, our Excel. You need to use the largest value refinement or the shortest edge, which is related to the largest value. So our largest value is 6. Okay, so to correct everything, let me put here 6. And I know, look at that, wow, this is super small. So 6, 5, let's leave a value. So look at that. Well, also I was in the wrong one. Okay, so it's final relative, and let me put 6 here. And see that bam, 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 probably will fail in 20 already. Well, pretty much like in previous case, because this one I'm not changing. This one will change. If you change the aspect ratio you want to add in this one, they're going to change. Okay, so aspect ratio have also a strong influence in this stuff. So let's go and put 10. Okay, 10, and we have the values there. Okay, and bam, 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 bam. It's BL here. Let me put 10 here, everything in standard, and boom, boom, we need to add the other one, which is mesh. If I will recall, this is the syntax. It should be, and now let's run. Okay, there you see that I didn't practice this. Okay, it raised it 3, so I didn't need the mesh. We can repatch it, so there is no problem. So let me erase that. Okay, so there you go. 89, that's acceptable. You can see where you have problems, non-orthogonality, boom, boom, boom. Okay, and always visualize your mesh. Sometimes that check mesh can lie. In this case, likely not. I know that those transitions are terrible. So there you go. Nice boundary layer, and see that this is what is happening. Now this is one of the issues also with relative sizes. So remember, relative is percentage in reference to the cell next, next to the surface. Now, so that's why you get this. So if you want to get something uniform, use absolute sizes, which by the way is way more difficult to control than this. So let me hide here and here, but now I can access here. Let's see, cell level and surfaces there. So yeah, terrible. So you have 10, 10, 10 all around, and here's where you start to have those problems as expected. All these issues when you have all these transitions. Look at that here, you're having those transitions 2 to 1, and everything starts to fail. Okay. However, another trick. So as usual, you can play with mesh quality metrics and so on. So let me go here. Well, now you don't need to play with this. No. Let me go put here 1 mean completely disable all that stuff. Okay, I already have a low value there. Okay, so just one iteration, everything disabled. So look at that, we have 001610. Okay, actually, yeah, I think it should be 00 or 4. Yeah. Okay, yeah, no, we have different refinement. Yeah, that needs to be corrected as well. In any case, different refinements, and there you go, 91%. So we have much better now. So 91% is a good value. Okay, let me go here. Next. Close here, sphere, patch, put there, and there. Very cool, very nice, but I want to see this. Let me go there, let me put surface layer, and it did, as you can see, a much better work. Okay, and probably then you have some collapsing there, some collapsing here. See that this transition is really bad. Okay, so there you go. This to solve this problem, yeah, I think there's no easy way. This way is uniform refinement, or try to reduce this, because we're going from 2 to 6, which is too much. Probably a 4 to 6 will give you, probably not likely, will give you much better results. And then the next step, let's patch that. Okay, so it's always going to patch the last one. So, and let's see now that we have that patch. I really love that utility. I use it a lot, believe it or not, when I do a lot of parametric studies, optimization, and you can imagine that there you need to repatch and something. So I use a lot that utility. And surface here, and there you go. It has been patched, and we have access to also the boundary layering for me. So, by the way, it's not something that is foolproof. This utility now sometimes give you problems, but it's cool nowadays. It's something cool. So. Okay, I don't have that feeling for available in for, but in any case, we have all the boundary layer information available there. So yeah, this is it. This was another small twist. Since that visit here, check your quality in Paraview as well, aspect ratio. I hope I convinced you that is the most important one, and also you are convinced and sure that this refinement ratio 2:1 is terrible. Okay, quality issues, but also if you are doing scale resolving simulation, less a lot of numerical diffusion. But from the visual point of view, beautiful excess meshes. In any case, my religion is poly, but every mesh is going to give you, if you know what you're doing, you control your geometry, you're going to get always good results. So that's all for this video. Then we have another one to visit, okay? And hopefully we demystify much better all these issues, boundary layers. See that very easy geometry doesn't grow. Then by changing here and there and knowing what is happening, you can get meshes now to 10 to the minus 6, 7. Well, I haven't done 10 to the minus 7, but I think it shouldn't be a problem. So yeah, that's all. Thank you. See you next time. Bye.